What if I told you that Helen, a 73-year-old grandmother from Boston, stopped going to family dinners? Not because she didn't love her family, but because she'd lost 12 teeth and couldn't chew properly anymore. Helen had done everything right. She brushed twice daily, flossed religiously, visited her dentist every 6 months. Yet by age 70, half her teeth were gone to periodontal disease and decay. Her dentist offered the standard solution, $60,000 for full mouth reconstruction with titanium implants. Helen couldn't afford it. More importantly, she didn't want metal posts drilled into her jaw. "Isn't there something more natural?" she asked. Her dentist looked at her with sympathy. "I'm sorry, Helen. Once a tooth is gone, it's gone forever. That's just how the human body works." But here's what that dentist didn't know, what most dentists still don't know. Helen's body never actually lost the ability to grow teeth. It just turned it off. And right now, in labs across the world, researchers have figured out how to turn it back on. I'm Dr. Mohammed Koch. I've placed hundreds of dental implants over 20 years. Titanium posts, bone grafts, the whole mechanical process. But lately, I've been asking myself a question I never expected to ask at this point in my career. What if we've been solving the wrong problem this entire time? Today, I'm going to reveal the shocking scientific breakthrough that could make dental implants obsolete, and why Helen's body is preparing to do something her dentist said was impossible. Disclaimer: this is for educational purposes only. Consult your healthcare provider for personalized dental advice. The hidden epidemic nobody talks about. Before we get to the breakthrough, let me tell you what's really happening in mouths across America. According to the World Health Organization, 30% of people aged 65 to 74 worldwide have no natural teeth left. In the United States, the CDC puts that number at around 26% for people over 65. But here's what nobody explains. Partial tooth loss is far more common and far more devastating. By age 50, the average American has lost 12 permanent teeth, including wisdom teeth. That's from the National Institute of Dental and Craniofacial Research. I see this constantly in my clinic. Someone comes in, maybe mid-50s, brushes twice daily, flosses, and they've still lost molars. Periodontal disease affects 70% of adults over 65, according to CDC data. Tooth decay remains the most common chronic disease globally per WHO statistics. But here's the part nobody warns you about, the part that destroyed Helen's quality of life. When you lose a tooth, the real damage starts afterward. A 2018 study in the Journal of Prosthetics found that within the first year after extraction, patients lose up to 25% of the width of their jawbone in that area. Once that bone is gone, it doesn't come back on its own. The adjacent teeth become unstable. The whole structure cascades into collapse. Helen noticed this when she looked in the mirror. Her face started looking different, sunken, older than she expected. But the physical changes were nothing compared to the emotional devastation. "I stopped smiling in photos," Helen told me. "I stopped going to restaurants with my friends. I felt like I was becoming invisible." This isn't just cosmetic. Tooth loss is linked to malnutrition, social isolation, and according to a 2021 Rutgers study, even cognitive decline in elderly populations. Helen's story isn't unique. It's the story of millions of seniors who've been told the same thing. Once a tooth is gone, it's gone forever. But what if that's not true anymore? The problem with current solutions, let me tell you what we do today when someone like Helen loses teeth. Implants, dentures, bridges. Implants are considered the gold standard. The American Academy of Implant Dentistry reports success rates around 95% over 10 years. But let me explain what the glossy brochures don't mention. First, you need bone. If you've already lost too much, like Helen had, you need a bone graft first. That's another surgery, more healing time, more cost. A single implant in the U.S. runs anywhere from $3,000 to $4,500, according to 2023 American Dental Association data. Full mouth reconstruction, $60,000 to $90,000. Helen looked at that estimate and her heart sank. She was living on Social Security. That money didn't exist. But even when people can afford it, there are problems. About 10% of patients develop peri-implantitis, inflammation around the implant that can lead to failure. That's from a 2020 study in clinical oral implants research. Dentures are cheaper, but they're uncomfortable. The National Institute of Health notes that denture wearers have 20 to 25% less chewing efficiency than people with natural teeth. I've had patients tell me dentures slip during conversations, cause sores, and require constant adhesives and adjustments. Bridges. You have to grind down two perfectly healthy teeth to anchor the fake one. You're sacrificing good tissue to replace bad. But here's what bothers me most after 2 decades of doing this work. None of these solutions are biological. They don't have roots. They don't sense pressure. They don't remodel with your jaw. They're mechanical fixes for a biological problem. After placing a few hundred implants, I started wondering, why are we still doing it this way? That's when I discovered what researchers at Kyoto University had been quietly working on for 15 years. The protein that locked your tooth factory. Here's what almost never gets explained during a standard dental visit. Your ability to grow teeth didn't disappear when you became an adult. It was locked. Right now, inside your gums, the same tooth factory you had as a child is still there, but a specific protein has bolted the door shut. That protein is called USAG1. Think of it as a strict security guard standing at the factory gate. Its only job is to stop new teeth from forming. Dr. Katsu Takahashi is a molecular biologist at Kyoto University Graduate School of Medicine. His team has been working on this for over 15 years. In 2021, they published a groundbreaking paper. They genetically engineered mice to block USAG1 activity. The result? Complete tooth regeneration in mice that were born without teeth. These weren't just calcium lumps. They were complete teeth with enamel, dentin, nerves, and roots. The researchers didn't try to build a tooth in a lab. They simply unlocked the brake using a specific antibody. Think of your body like this. To grow teeth, you need an accelerator and a brake. The accelerator is a signal called BMP, bone morphogenetic protein. It tells your stem cells, start building. When you were a child, this accelerator was floored, but once your adult teeth were in, your body pulled the handbrake. That brake is USAG1. The problem is, even if you lose a tooth tomorrow, that brake stays locked. Your body wants to repair itself, but the guard won't let the signal through. In the Kyoto study, researchers did something incredible. They removed that guard. Within weeks, new teeth began to grow. When Helen learned about this research, she asked me the question everyone asks. If I take a medicine like this, will I start growing teeth in my ears or on my chin? The answer is no. Your body has positional memory. It already knows exactly where a tooth is supposed to be. The treatment doesn't create a new map. It just gives the construction crew permission to follow the old one. The international race to regrow teeth. This isn't some fringe lab working in a basement. This is a coordinated international effort backed by peer-reviewed science and institutional funding. At the University of Pennsylvania School of Dental Medicine, Dr. Song-Tao Shi's team has been investigating dental pulp stem cells, the cells inside the soft tissue of your teeth. In a 2013 study in the Journal of Dental Research, they showed these cells could regenerate dentin and form tooth-like structures in animal models. At King's College London, Professor Paul Sharp's group found that cells in the gums retain a kind of memory of tooth development. In 2018, they published research in Nature Communications showing these cells could be coaxed into forming tooth tissues when exposed to the right biochemical signals. They even used a drug originally meant for Alzheimer's to stimulate human dental pulp. The result? The dentin actually regrew. It wasn't a whole tooth yet, but it proved the principle. If you give the right signal, the human body responds. At Harvard's Weiss Institute, researchers published findings in 2023 in Cell Reports demonstrating that low-intensity ultrasound could stimulate stem cells in the jaw to start differentiating into tooth-forming cells. This is not one lab. This is an international effort. And here's what strikes me about all this research. For decades, we've been trained to think of the body as something that breaks down and needs to be fixed with external materials. But what if the body just needs to be reminded of what it already knows how to do? The evidence in animals and humans. We've already seen this work in animals like ferrets and dogs, which have jaw structures very similar to ours. They didn't just grow bits of teeth. They regenerated complete functional teeth with bone and tissue. But what about humans? Actually, we've already proven we can do this on a smaller scale. The King's College London research I mentioned earlier used human dental pulp and successfully regenerated dentin. If this is so close, why can't you get it at your dentist's office today? As of 2025, human clinical trials are finally starting. They're beginning with people born without teeth, a condition called congenital tooth agenesis that affects about 7% of people. This is phase 1, the early stage where we prioritize safety over speed. The science is no longer the question. The mechanism works. We're simply waiting for the safety data to catch up. We've moved from if this is possible to when it will be safe. What Helen decided to do when Helen learned about all this research, she sat in my office with tears in her eyes. "So, I'm just a few years too early," she said quietly. It's a valid feeling, but I told her something important. "Helen, if you can preserve your jawbone and gums now, keep them as healthy as possible, you're essentially saving a seat for these regenerative treatments that could be available in the next 5 to 10 years. Helen made a decision that day. She couldn't afford $60,000 for full implants, but she could invest in preservation. She committed to rigorous oral hygiene to prevent further tooth loss, regular cleanings to manage her periodontal disease, calcium and vitamin D supplements to maintain bone density, avoiding foods that stressed her remaining teeth. "I'm betting on science," she told me. "I'm betting that in 5 years, my body will be able to do what it was supposed to do all along." The bigger picture: regeneration over replacement. For the last 100 years, dentistry has been a game of placeholders. If you lost a tooth, you replaced it with metal, ceramic, or acrylic. Something that looks like a tooth but isn't alive. But we're entering a new era: regeneration. We're moving away from replacing what's lost and moving toward regrowing it. This isn't just about your smile. It's a complete shift in how we think about aging. We've always been taught that once something is gone, whether it's a tooth, joint cartilage, or nerve tissue, it's gone forever. But biology is much more flexible than we were led to believe. Your DNA doesn't delete the manual for building your body just because you turned 60. The instructions are still there. They're just under lock and key. The Kyoto team didn't invent a new organ or install a foreign object. They simply gave the body permission to do what it already knows how to do. Think about the implications. If we can unlock the code for teeth, what's next? Stanford is currently looking at heart tissue regeneration. Johns Hopkins is investigating how to regrow spinal nerves. The Mayo Clinic is exploring ways to regrow cartilage in arthritic knees. Tooth regrowth is the proof of concept for a new kind of medicine, one where we stop adding foreign materials to the body and start turning off the signals that hold us back. What you can do right now. If you're currently in your 60s, 70s, or 80s and dealing with tooth loss, I have to be honest, current options like implants, bridges, or dentures are still your best bet for immediate function. This regenerative technology isn't at your local clinic just yet. But, and this is a big but, if you're in the early stages of tooth loss, your goal right now is preservation. By keeping your jawbone and gums healthy today, you're essentially preparing your body for treatments that could be available in the next 5 to 10 years. Your preservation protocol: maintain rigorous oral hygiene to prevent further tooth loss. Get regular professional cleanings every 3 to 6 months. Manage periodontal disease aggressively with your dentist. Take calcium, 1,000 to 1,200 milligrams daily, and vitamin D, 800 to 1,000 international units daily to maintain bone density. Avoid habits that stress remaining teeth, hard foods, grinding. Consider bone grafts, even if you're not getting implants yet. They preserve the foundation. Some of you might feel frustrated, like you're just a few years too early for this breakthrough. But think about this. For the first time in history, we aren't just talking about plastic and titanium. We're talking about your own DNA. The first people to benefit from this will likely be children born with missing teeth. They will be the pioneers in upcoming clinical trials. But the shift is even bigger than just regrowing a single tooth. We're seeing breakthroughs in regenerating tooth enamel using special peptides, regrowing gum tissue using stem cells, strengthening jawbone using natural growth factors. For over 100 years, dentistry has been about replacing. Now it's about remembering. Your body hasn't forgotten how to build a tooth. It just needs the right signal to start. Helen's choice and yours. 3 years after our conversation, Helen is still waiting. Her jawbone is stable. Her remaining teeth are healthy. She's managing her periodontal disease successfully. I know it might not come in my lifetime, she told me at her last checkup, but I'm doing everything I can to be ready if it does. She paused, then smiled, something she rarely did before. And if it doesn't come for me, at least my grandchildren won't have to go through what I did. That's worth something too. Will you be able to regrow a tooth at the dentist next year? No. But we're officially living in a world where losing a permanent tooth might one day be as temporary as losing a baby tooth. We're no longer asking if we can regrow the human body. We're only asking when. And for the first time in history, the answer is measured in years, not centuries. Conclusion, a new paradigm. I'm going back to my clinic now. I've got an implant surgery scheduled this afternoon, a titanium post, bone graft, the whole traditional procedure. But as I prepare for that surgery, I'm thinking about something different. The paradigm is shifting. We're no longer just fixing a machine. We're finally learning how to speak the language of the body. Helen made a choice to preserve rather than replace, to wait for regeneration rather than settle for mechanical substitution. Not everyone can make that choice. Not everyone should. But for the first time in dental history, there's hope beyond metal and plastic. Your tooth factory is still there. The power is on. The blueprint is waiting. The question is, will you be ready when science finally unlocks the door? If you could regrow any part of your body, what would it be? Your teeth? Your joints? Your vision? Share in the comments. If this video opened your eyes to the future of regenerative medicine, like and subscribe for more groundbreaking health science. Remember, the story isn't over yet. And maybe, just maybe, it's worth preserving your jawbone a little longer than you otherwise would have.